Okay, so we're recording now. How did you go with those last two cases? Were you able to interpret the results and work backwards fairly easily? Yep, so I've got a couple of yeps there. So case 3.1, what was that? Yep, so case 3.1 was indeed APL rara. And so the immunophenotyping gave you that it was a more mature myeloid marker, because all of the HLA-DR and CD34 were negative on that one. And of course, the chromosomal analysis showed us that there was a balanced translocation between chromosomes 15 and 17. So what would you expect to see in a blood film of somebody with APL? First of all, what age group do you think they would fall into most commonly? Are they going to be children? Are they going to be young adults, or are they going to be older adults? Yep, young adults. And what would you see on the blood film, do you think? What sort of results would you see? Yes, the beautiful, the coin-on-coin lobed early myeloid cells. And yes, they're called coin-on-coin or butterfly lobe nucleus Chiari, and that's very indicative of APL. Yes, definitely acceptable in exam. Well done, Jordan. Gold star. Why are we seeing schistocytes in an APL?
Because the pro-monocytes have procoagulant factors in their granules, so it causes a coagulopathy / DIC, and then you get a hemolytic anemia due to the shredding of the red cells.
Lovely. Okay, so it's a microangiopathic hemolytic anemia, in fact, or I've forgotten the term that I've been teaching you, TMA. From thrombotic microangiopathic anemia, whatever I've called it. Yes, that's right. So that is commonly when you see clinical signs and symptoms for these patients, there can be some sort of a thrombosis or a coagulopathy showing in those clinical signs and symptoms. Yep, great, that's good. So the second one, case 3.2, what did you consider that to be? Lovely, yep, BALL with BCR-ABL1. So that is exactly it. So what's the population that we see this mostly in? Yes, so we often see BALL in children, don't we? But it's not usually with that, the BCR-ABL1 fusion gene. That tends to be more in adults. And why is that? What's the current thinking around that? The same age as adults who are prone to CML. Yeah, it's a blast transformation of CML. Yes, that's exactly right, Jordan. How does it? Yes, chronic myeloid can transform into acute lymphoblastic. And it's not magic, it has something to do with where that original mutation takes place, what level it takes place in. And with CML, even though we do get that, it is a mature leukemia, the original mutation or the initial mutation actually starts off in one of the very early hematopoietic stem cells. So when we do get a blast transformation, we can get that transformation across the lines into the lymphoid line. Okay, so that's what it is. So older adults, and what would we expect to see on the blood film? If this is a lymphoblastic leukemia, what would we expect to see in the blood film? Yay, lymphoblasts. Now, you may not see greater than 20% lymphoblasts, Gabby. Remember that WHO criterion is greater than 20% of blasts in the peripheral blood or the bone marrow. And particularly with ALL, we can get normal white cell counts, and we can get only 1 or 2 blasts seen in the peripheral blood. In fact, in 10% of ALL, you don't see any blasts. So that's why WHO has got that proviso that it's greater than 20% in the peripheral blood or the bone marrow. Okay, so what would we expect to see in the bone marrow? Hypercellular, yes. We're seeing blasts in the peripheral blood. Would we expect to see them in the bone marrow as well? Yes, we would. Okay, because remember that abnormal clone builds in the bone marrow first before spilling over into the peripheral blood. Okay. Rightio. Has anybody got any questions about those two reverse case studies? So CD45 is a marker that is used. It's another gating marker that's used to differentiate your cells. It's a marker that is most common on, well, it's not common on all white cells, but it's particularly concentrated on lymphocytes and blood and cells of the lymphoid line. And it can also be present in blast cells as well. So it's just another way of, you know, like your forward scatter, side scatter. It's just another way of helping to separate out your populations to work out which one you're going to focus on more carefully. CML can transform into either AML or ALL, but CML when you get that ALL with the BCR-ABL mutation, then that is an indication that it is probably a CML that has transformed and gone through that blast transformation. Okay. Any other questions? So did you find doing those working backwards on the cases useful? No, you don't have to remember the P and Q. You do need to know which chromosomes have transformed. And you need to know if a fusion gene has formed and if there is a specific a de novo protein. Okay, so if there aren't any more questions, I'll stop the recording. Mike, hang on, I'll just stop the recording.